Today I'm going to be making an injection mold for a spoon. Every now and then I do some projects for Richie Manning of Manning Innovations. He has a company that makes injection molding machines, and therefore he has customers who buy his machines and want molds made. He often makes the molds himself, or he sends them out to local mold makers, but every now and then he sends a job to me. Now this particular job he sent to me because it has a lot of curves, and my machine, with its high spindle speed of 30,000 RPM, does a really good job of being able to mill these types of curves without taking a whole lot of time. Now this particular part is not ideal as it is now for the material the customer is going to be using, so he wanted me to make some changes to the model itself. This is the model that the customer sent. The main issue with this is that some of these cross sections are fairly thin. I'll go ahead and do a cross section. And look at the other side. So when we look at the other side, you can see this gets really thin here, and then there are some sections that are thin there as well. Now, what he wanted me to do is to make these all a fairly uniform thickness, or as uniform as possible. So I created this right here. If I hide the splitting tool, I'll explain that in a minute. I'm also going to hide this construction plane. You can see we now have the uniform thickness. Now I'm going to walk you briefly through how I created this, but I'm not going to go through every single step. So let me turn on the original, well, let me go back in history to right here. And this is the point where I have just the original spoon imported. I did an insert derive. Insert derive allows me to modify things. The very first step is I'm going to remove this fillet, basically that surface as well as that surface. And you can do that by selecting those surfaces and pressing the delete key, but to make that work you have to select a whole bunch of different surfaces. You know, these two surfaces there, those two there, those two there, and then around to the other side. And that's what I did with this operation. So when I click the next button, you can see this has gotten rid of the fillet. I tried to do the same thing with the fillets on this other side, but I just could not get it to work. It kept failing. So what I did instead is I created this sketch, which is basically a cross section. I created a plane and then I projected various points and then also extended this out. So this would be about the same thickness here at the end. And then once I created that cross section, I could extrude it to create this part here. This obviously isn't the right shape. So this is where next thing I did is I came and created the outline from above, so that I could then use that as a cutting tool to get approximately the right shape. You can see here that it doesn't line up perfectly with the spoon because the spoon has an angle here. It's not straight up and down. We'll come back to that later. Okay, now to create the bowl, let me hide the handle. I created this surface. If we take a look at this operation, you can see I did two things. First is I selected this surface to be the surface that I wanted to copy. And then the second thing I did is I said I wanted to move it down by 0.03 of an inch, which gives me that. If we look at the original spoon, you can see that that surface does a pretty good job of lining up with the new handle that we have. And then the next thing that I did is create a copy of that surface, which you can see right there, and I'll hide these two right here. Actually, I'll keep the new handle. And again, that copy of the surface is designed to come fairly close to the new handle. These two surfaces will then allow me to basically fill in the sides and turn this into a solid model. I did it this way because I tried a whole bunch of other things and this is the only thing that I got to work. So this is adding the sides, stitching it together, and that creates the solid model. So at this point I have the spoon bowl as one piece and I have the new handle as another piece. And I decided to keep those separate and then just do some work to kind of bring them together. Okay, so moving forward a little bit, I'm going to skip some of these details here. I created this sketch along the side. And the purpose of this sketch, you can see it goes pretty much down the center of the part. So the purpose of this sketch is to represent the parting line. And then I used that sketch to create a surface, as you can see here, that I'm going to use as the actual parting line. And then moving forward, I'll turn that back on, the various other things, but that's the important part. Given those two things, basically the spoon itself and the parting line, that's all I need to be able to create the mold. Switching over to the mold, I created another file, and the first thing is I imported the spoon itself, as you can see there. And then the next thing that I did, I positioned things a little bit. And the thing here, let me just show from the top, is what I did is I rotated things so that I could fit the spoon better into the dimensions that I had for the mold. Richie specified the mold as being 6 inches wide by 3 inches tall. And I like to have as much margin between the part and the edge of the mold as possible. If it's too tight, you could have problems keeping the mold halves together and you can get flash or you can get blowout of the mold. So I rotated this so that I could get the best margins all the way around. And then once I did that, then I could extrude the material. And this is going to be split in two pieces, the A and the B side, using this parting line. But before I did that, I wanted to remove the cavities for the two parts of the spoon itself. And then we go ahead and use the parting line here. So if we look, we now have these bodies. So we have the top, we have the bottom, and then we have part of the spoon that's left over, which we'll just ignore. What I wanted to do then is take each of these and convert them into a component. So here I've converted the bottom into a component. And then same thing for the other side. So now I have the two halves of the mold as components, which means I can go ahead and hide that. And now you can see I have the mold half right there for one half of the mold. Then a little bit more work. This is adding the alignment pins. I added the alignment pins to both halves, as you can see there, or I should say the slots for the alignment pins. This is starting to add the gate for injecting the plastic. Richie wanted me to have a fairly wide gate. The advantage of a wide gate is that it means that it takes longer for this to solidify. The minute this freezes, you can no longer fill the mold. So having a wider gate makes it easier to fill a mold where that's long and slender like this, where the plastic needs to move quite a distance away from the gate. And then I added the sprue to bring plastic in. And then this next part is because the nozzle has a radius on it, so we want the nozzle to seat very well. And then what I do is I basically subtract these from the mold itself, and now you can see the seating area for the nozzle. Next thing is I added a couple slots, both here and there. These slots are for a screwdriver that allow you to, let me show it this way. So you put the screwdriver in here and twist one screwdriver on each side, and that makes it easy to pry the mold halves apart. Then the last two features are air vents. So these are both about 1/1000th of an inch deep, and they are at the extremes of the part. So as the plastic is flowing, it's pushing against the air, and these small vents are shallow enough that they won't allow the plastic to enter, resulting in flash, but they will allow the air to escape, and that makes it easier to fill the part. The milling is fairly straightforward, but it does take a while. It takes a little bit more than 2.5 hours, as you can see. And a lot of that is because of all the curves that are on here, both for the spoon itself and for the mold, because the parting line, as you can see, is definitely not flat. So the first thing is to do the adaptive clearing, which is using a 3/8 inch diameter end mill. Then it's spot drilling, pocketing, and doing a 2D contour for the alignment pinholes. Doing a pocketing for the slots that will be used to pry the mold halves apart using a screwdriver. Then we have the contour for the ball end of the nozzle. And then here's the long operation. I'm using a fairly large diameter ball end mill to create the smooth party line as well as to smooth out a lot of the spoon itself. But it does leave an area here that doesn't clean up very well, so we have to come back after cutting the sprue and the gates with a smaller diameter end mill. So this is using a 1/16 inch diameter ball end mill, fairly long reach, to clean up the corners there. And then after that, this is doing a fairly small step over using the same tool. And the idea here is to minimize the amount of sanding and polishing that I have to do on the mold by letting the machine do the work for me. And then finally another pass along that fillet with a even smaller end mill. As you can see, it's a very small long reach end mill, 1/32 of an inch in diameter, and that cleans it up very nicely. I give this stock a good whack both on the front and the back with a dead blow hammer, and then check the parallels to make sure that it's firmly seated. And this is to avoid jaw lift causing it not to be correct. And then using my 1mm tip on the probe to get the left side of the stock, and then around to the back to get the back of the stock. I realized I was using a cut that was too aggressive. This machine suggests much lighter cuts, so I stopped it. And then picked up again with a new toolpath that was less aggressive. This is part way through the roughing, and you're starting to see part of the spoon, the bowl itself, start to appear. Sometimes I'll just sit here and watch it because it's kind of mesmerizing to see it start to slowly take shape. You can see that it first cuts fairly deeply, and then it comes back and adds more and more detail at different levels. And here it's just about finished with the roughing operation. And then spot drilling, the two locations where I'm going to drill deeper holes with just a regular drill. And it's currently changing to the drill bit, and you're going to notice that it changes to the drill bit and it just stops. And that's because I didn't have the right tool length, so it aired out. And so I put the tool setter back into the machine, which is easy to do. Measured the length of the tool, the approximate length, put it into the controller, and then hit the right buttons, and it came, measured the tool. As you can see here, it's coming down, measuring it. And then I could continue with the job of drilling the two holes where the alignment pins will go. Even though this is a 1/4 inch diameter ball end mill, I'm still running it at 30,000 RPM because at the tip that's a fairly small diameter, so it needs to run at the full speed. I'm running this over the entire curved part of the surface, which is pretty much the entire surface. Everything is curved on this except for the two slots for the screws. So it takes a while, but eventually this finishes milling. Then a 1/16 inch diameter end mill to start cleaning up the fillet at the edges of the spoon. And finally a 1/32 inch diameter ball end mill to finish cleaning up the fillets at the edges of the spoon. So this is the finish I got directly off the machine. I used tool paths that were fairly close together to try to minimize the cusp height, so that in order to smooth this and to remove the tool marks with polishing and sanding, etc., it wouldn't take too much work. So that's the next thing that I'm going to do, to start to polish the cavities of the two mold halves to eliminate the tool marks. So I've shown these before. These are polishing sticks, I'm not sure what they call them. Cushion tips, ultrafine cushion tips. So this has some abrasive on it. And so I can just start to polish using this stick. And I put a little bit of WD-40 on here. So the WD-40 is going to act as a lubricant and to help keep it from clogging. You can see that it's already starting to change colors, and that's an indication that it's doing its work. So I'll just go at this for a few minutes and then clean it off and see how we're doing. Now with the small amount of cusp that I have, It shouldn't take too long. And I don't know if you can tell very well, but the tooling marks are already starting to go away. So I'll keep at this, but it shouldn't take very long to get rid of the tooling marks on both of these molds. By the way, this one is marked as 4,000 grit, I believe. Oh yeah. The tool marks are just about gone. I see a little bit in the middle there, but they're almost gone. So yeah, I'll keep at this and shouldn't take too long. Now in this section here, I cleaned up with a 1/4-inch ball mill. And so the 1/4-inch ball mill, I think, has slightly greater distance between the cusps. So I'm not sure if it'll clean up as quickly. We'll find out shortly. Whereas over here I used a 1/16-inch diameter ball mill, so much closer spacing. Okay, I still see the tool marks, so I think I'll take some sandpaper to the spoon, the cup or the bowl or whatever it is, but for the handle, this will be just fine. So I'll keep at this, and I'm guessing probably no more than an hour or so to polish the molds. Okay, I'm going to start with a piece of Scotch-Brite that I have here. And that does get rid of the tool marks. There's some still there. Of course, it adds scratches, which I'll be able to polish out. Okay, I'm seeing some tooling marks still up there, so I'm going to use some Scotch-Brite on that. And there's a few shadows of tooling marks along there, so I'll give that another shot as well. Here you can see the difference between sections that I've sanded and polished, such as here, versus this section here, which still has the tool marks. The tool marks, of course, are not that bad here, but they're more noticeable on the spoon portion. And so it doesn't take that long, as you saw, to get rid of the tool marks. The request was to eliminate the tool marks, not to polish the molds, so this finish should be plenty good enough. I mean, it's starting to look close to polish because it's 4,000 grit. But it isn't actually polished, because I would take that up to an even higher grit, and then it would be glossy smooth. The final step before I send these off to Richie is to use some removable Loctite to glue these dowel pins into place. I use removable Loctite because that does give me the ability to use a punch from the back, because I have a hole that goes all the way through, to punch these out in the future if I need to come back and mill the surfaces. At this point, I packed up the mold and sent it off to Richie. Richie then tested the mold on one of his machines before sending it to the customer. The customer is going to be using one of the machines provided by Richie. with the mold that I created.
Hey John, welcome to my shop. So tonight we're going to shoot your mold and show you a little bit about the machines. This one's got the 15-ton hydraulic clamp, and then over here is a 300. This one's got the 25-ton, but you can put any one on any machine because it's totally modular.
Startup of the machine is similar to mine. You turn on the power. He has 2 heat bands and therefore 2 controllers, so he can set them separately. Then setting the initial injection pressure. On his machines you can fill it with quite a bit of plastic and don't have to worry about keeping the plastic below the top of the cylinder. So unlike my machines which have a valve, he can just purge it right away without having a purge block underneath. Here's applying a mold release, which is something I typically don't need, and this mold probably doesn't require it at all. This is an interesting setup. You can see he inserts the mold. That's not too different from my machines. But then he has this electric-powered hydraulic pump that provides the pressure to the clamp. And then he pulls down to inject, waits for it to fully pack. And then he can release the pressure after it's had time to pack, let it cool a little bit more, and then he can remove it from the machine and demold the part. This is releasing the hydraulic pressure to release the clamp so he can pull the mold out. Here's a close-up that will allow you to see a little bit better what's going on. Putting it into the machine, and then when he turns on the pump, you can see the ram move right there. And now it's fully pressurized, and then he can start injection right there. The packing time to wait for the part to fully fill and to cool down so it shuts off. And then he can turn to release the pressure, and you'll see the clamp move back a little bit right here. And then he can remove the mold and remove the part from the mold. It's stuck on the other side, kind of. I mean, it doesn't really stick at all. This doesn't really have anything that grabs onto the parts. Here's another view that allows you to see where he's closing the clamp. Then he turns on the pump, injects. You can see the hopper move down with the cylinder. And then release the pressure. You can see the cylinder moved up, release the hydraulic pressure, and then you can take the mold out. And again, you're going to see just how easily the part falls out. So it's not really grabbing onto anything. The final bit is to cut off the gates. This is something I don't normally show, but it's something that I always do on parts before I send them to the customers. I hope you found this episode interesting. Please help me grow the channel by subscribing, giving me a thumbs up, commenting below. And if you want to support me at even the next level, totally optional, I have a link below to Patreon. I set up a Patreon account recently. Thanks for watching, and I'll see you next time.